Okay, now that we got that out of the way, we have some more room to work because we're going to be solving radical equations. If we want to look here, there's an equation there. It says the square root of x, and then you subtract 24 from that. That's going to be equal to 0. Well, the directions, you got to make sure you read the directions. It says solve the equation and check for extraneous solutions. Well, what would be extraneous solutions? Extraneous solutions would be any solutions that would cause that x underneath the radical to, possibly be negative. I don't think we're going to have to worry about it so much in this problem, but in future problems we will have to check that out. So let's look here. If we're trying to get x by itself, first step would be to add 24 to both sides. So once we do that, those 24s cancel, leaving us with the square root of x on the left side of the equal sign, and 0 plus 24 is 24. Now, what is the opposite of taking the square root? Well, that's squaring. So if we square the square root of x squared on the left side, we also have to square the right side. And so once we look here, the square root of x times the square root of x is going to be x. And 24 times 24, I don't know that right off the top of my head. So let's go ahead and multiply this. $576. So x is going to be equal to 576. Okay, well, checking for extraneous solutions, all that on the screen there, I'm going to substitute 576, since it's x, plug it right in there for x. So square root of 576 minus 24 is equal to 0. Can you do the square root of 576? Well, yeah, it's 24. So we know that since we can do that, we can figure out the square root of 576. We know that 576 is not an extraneous solution. So extraneous solution just means a solution that we cannot have. And we can have square root of 576. So our answer, x is equal to 576. Don't worry, they do get a little more challenging. What I'd like to see is if you can solve this one out on your own, and then you pause the video, work it out, and then check your solution with mine. I believe our first step is to add 18 to both sides. So I've added 18, and I've added 18. How do we get rid of taking the square root? Well, we're going to square both sides. And so that means x is equal to 18 squared. Let's see, 64 and 44. Yeah, that's what I thought it was. X is equal to 324. And if I plug it in there for x, I get the square root of 324, which I am allowed to do that. I am allowed to have the square root of 324. So solution, x equals 324. Okay, this one here is solved the same exact way. The thing that we're looking for as far as extraneous solutions is that 3x plus 2, what's underneath the radical there, 3x plus 2 cannot be less than 0. What's that mean? 3x plus 2 cannot be negative. So let's go ahead and work our way in solving this out. First step, remember that the radical is a grouping symbol, and when we're trying to solve for a variable, we work our way backwards through the order of operations to solve for the variable, and you notice grouping symbol comes last. So we have to deal with everything outside of the radical, which happens to be the plus 2. We have to deal with everything outside of the radical first in order to, work with what's inside the radical. So how do we get rid of adding this 2 to the radical? Subtract 2. That leaves us the square root of 3x plus 2 is equal to negative 2. Next step, square both sides. So that leaves us 3x plus 2 on the left side, because squaring and square root cancel each other out. And what is negative 2 squared? That's negative 2 times negative 2, which is a positive 4. And from there, what we want to do is we want to subtract 2, leaving us with 3x is equal to 2. Divide by 3, divide by 3, leaving us with x is equal to 2 over 3. Okay, so we have the value for x. Now we need to check to see if it's extraneous. And what we're going to do is we're going to look at this right here. So if I have 3 and I have x is 2/3 plus 2, is this going to give me a negative value underneath the radical? Well, if I'm multiplying 3 times 2/3, I know I can reduce the 3's to 1's, leaving me with 2 plus 2, and 2 plus 2 is 4. Can I actually have the value of square root of 4? Yes, I can actually have the value of square root of 4 because we know it's 2. Okay? So as long as we're able to have this value underneath the radical, we're good to go. Let me see you solve this one on your own. And you pause the video, hit play when you're finished, then I will have worked through a solution for you. I see the first step. Remember, that's a grouping symbol. We deal with it last. So we add 5 to both sides, leaving us with 6 is equal to the square root of 4 minus x. And you have to pay attention. That's a plus sign. If it was a minus sign, you would have to have brought it down. But it's a plus sign, so we can really just make it invisible at this point. How do we get rid of the square root? Well, we're going to square both sides, leaving us with 4 minus x, and 6 squared is 36. Subtract 4 from both sides. Don't forget your negative sign with the x. And 36 minus 4 is 32. Now, how do we get rid of the negative sign in front of the x? You can do one of two things. Divide by negative 1, or you can multiply by negative 1. And so, that leaves us x is equal to negative 32. Now we have to check for an extraneous solution here, because there's a possibility that we have a negative value underneath the radical. Underneath the radical, we have 4 minus, and x is equal to negative 32. Remember, if we have minus and negative, that means plus. So that leaves us with the square root of 36. Are we allowed to have 36 underneath the radical? Yes, we are. So we know that negative 32 is not an extraneous solution, and that is the solution to this problem. Here's one. Let me see what the next example is. Here's another one. I'll work through this one. If you want to pause the video and you think you can do this one, you pause the video and then hit play when you're finished and check it with my solution. Subtract 17 from both sides. That leaves us with -7. Cancels, so then that leaves us 6x plus 7 underneath the radical. We have to square both sides, leaving us with 6x plus 7 is equal to -7 times -7 is 49, positive. We're going to subtract 7, leaving us with 42. So 6x is equal to 42. Divide both sides by 6. X is equal to 42 divided by 6 is 7. So let's check for extraneous solutions. 6x, x happens to be 7, plus 7. Well, 6 times 7 is 42, plus 7. So that would be the square root of 49. And we are allowed to have 49 underneath the radical. Okie dokie. Let's look at this one. This one here is a little bit more challenging than what we've been working with. So I want to make sure I go through this one with you. Well, we notice here's the radical. There's nothing outside of the radical that we have to get rid of on the right side of the equation. But we do have to try to get this x away from that too, and possibly try to combine it with this x right there. So our first step, well, we know we have x by itself here, and we do not have x by itself here, so that has that 2. That's going to be our goal, is to try to get that 2, try to get this 2 away from x. So first off, how do we get rid of the square root? Square both sides. Square both sides. So that leaves us with 2x minus 1 on the right side. Now this left side, remember, if we square a binomial, that means we're supposed to do this. So first off, x times x, x times -2, -2 times x, and -2 times -2. Combine like terms, so that gives us x squared minus 4x, carry your like terms, plus 4. That's equal to 2x minus 1. Okay, you should have already learned that when we have an x squared, we're going to try to solve this by factoring. So we have to be able to get one side of the equation set equal to 0. Since a right here, wow, I don't know what that was. Since a right here is positive 1, I like x squared to be on the left side of the equal sign. So that means I want to subtract 2x, and I want to add 1 to both sides. Subtract 2x and add 1 to both sides, leaving us with x squared minus 6x plus 5 is equal to, canceled out, 0 is what we have left. Let's get a little more room here. Okay, so now can you give me, let's see, two numbers that multiply to give you positive 5 and two numbers that add up to give you -6. How about -5, -1? They add up to give you -6. So since a is 1, I can go ahead and break my factors down into x minus 5 and x minus 1. Now we're supposed to solve here, so x minus 5 equals 0 in one case, x minus 1 equals 0 in the other. Add 5 to both sides, x is equal to 5. Right here, we're going to add 1 to both sides, so x is equal to 1. So that's what we have for our two solutions, 5 and positive 1. Now remember, we're always, anytime we have a radical, we're supposed to check for extraneous solutions. So let's check for extraneous solutions. Let me erase some of this so I have some room to work. We said we're going to have two cases where x is equal to 5 and x is equal to 1. Those were the two numbers that we found already. So to check for extraneous solutions, let's start with 5 and plug it in. 5 minus 2 is equal to the square root of 2 times 5 minus 1. 5 minus 2 is 3, and 2 times 5 is 10, minus 1 is 9, and so therefore 3 does equal to the square root of 9 is 3. Okay, so 5 is the solution, so we can say 5 works. Okay, we've checked 5. Now let's check 1. So we're going to have 1 minus 2 is equal to 2 times 1 minus 1. All right, underneath the radical, 2 times 1 is 2, and then that 2 minus 1 should give us the square root of 1. And what's the square root of 1? That's 1. But if we look on the left side, 1 minus 2 is negative 1, and negative 1 does not equal positive 1. So this is going to be the extraneous solution. 1 is an extraneous solution because you cannot plug it back into the original equation and get it to hold true once you plug it back in. And we should know that when you take the square root of a number, you probably shouldn't be getting a negative number. So the square root of whatever it is we're working with should always be a positive value. So the solution, even though we found 5 and 1 to be solutions, the only answer that we can say for this problem, x equals 5. That's the only answer we can have. That's all we have at this moment on solving radical expressions. We will see you on the next round.